Summarize. When we get a quadratic equation, an equation that has an x squared in it, x squared term in it, three different types of solving. Okay. Number one, if there is no x term in the quadratic equation, isolate the x squared and take the positive and negative square root to solve. So that means it's going to look something like this. Or there could be a number here, who knows? But there's no x term. Okay? If there is an x term, try to solve by factoring first. That means you get everything on one side, 0 on the other, and then you factor. And it could be GCF factoring, it could be x squared trinomial factoring, it could be ax squared trinomial factoring. So examples would be like x squared minus x equals 0. That's got an x squared term, or an x term. So we're going to have to do factoring if we can. That's one where we would do the GCF. Here's one where we would do x squared trinomial. Here's one where we would do ax squared trinomial. What would I have as a middle term? I could have 7x. Those are all examples. They can be factored. I may give you a specific question and say, solve it by factoring. Okay? Which means obviously it can be factored. Finally, if there is an x term and it can't be factored, use the quadratic formula. And you will be given the quadratic formula. You don't have to memorize it, because I'm more concerned about how you are able to use it. So an example would be, it looks like it might be a factoring question. But you won't be able to factor it. So run those through your head. Look for the x term first. If you don't see one, number 1. If you see one, numbers 2 or 3. So the first one, is there an x term? Yes. What is the x term? Say the whole term. Negative 2x is the x term. So that means we've got to solve it by factoring or the quadratic formula. Well, this is an x squared trinomial, so we can try factoring first. Everything's already on one side. So we know it's going to be x and x, and we are looking for two numbers that add up to negative 2, but multiply to negative 15. Juliana? 5 and 3? Not quite. Negative 5 and positive 3. And remember, we're not done. Some students make the mistake that as soon as they factor, they think they're done. We have to set each factor to 0 to find the possible solutions to this equation. So what value of x will make x minus 5 equals 0? 5. What value of x will make x plus 3 equals 0? Negative 3. And those are our two solutions. B, do you see an x term? No x term. There's no x. There's an x squared, there's a number, but there's no x term. So that means get the x squared by itself. So what will this equation look like when I get x squared by itself? X squared equals 49. You take minus 49 over to the other side by adding 49. That's simple algebra. Then we take the positive and negative square root of 49, and then we've got to look and see, can we take it exactly? Can we simplify it? Can we do nothing? We can take it exactly to get plus or minus 7. Absolutely, because there's two answers. If you just wrote 7, you get 1 out of 2. No. We're not going to do C. Yeah, it could be. Well, I mean, it is an ax squared trinomial. The question is, can we factor it? So this is one of those ones when if I give you the instructions, solve the following quadratic equations, you can use any method you want. Okay? The quadratic formula would work for every single quadratic equation, but it's very inefficient for some. But when you encounter something like this might take a while to factor. Okay? So unless you are told to factor this or solve it by factoring, probably want to go to the quadratic formula. Maybe you might want to see if you can factor it, play with a couple of numbers, but don't spend a bunch of minutes on it. So what's A, B, and C? Okay, so we're going to have negative 14 plus or minus negative 14 in parentheses squared minus 4 times the value of A, which is 6, times the value of C, which is 8, all over 2 times the value of A, which is 6. So we are going to get some big numbers. Simplify here, please. Here. Thank you. Minus, simplify here, please. How much? Okay. And then over 12. And 196 minus 192 gives us 4. Okay, so what can we do with that square root? Yeah, we can take it exactly, can't we? So 14 plus or minus 2 over 12. So that means there's going to be no square root in the answer. That means we could have factored it. Now what? How many answers are here? There's 2 answers here, right? 14 plus 2 divide 12, and 14 minus 2 divide 12. So I have to evaluate those. So I get 16 over 12. Can't divide it cleanly, but I can reduce it. 4 over 3. And then this one becomes 12 over 12, which is just 1. So our 2 answers are 4/3 and okay, so that could have been a question where I said solve this one by factoring. You do have to know how to do the factoring.
And then it honestly compares like
Yeah. Like, well, I mean, if you can take this exactly, you've got to split it up to get the final answers. Okay? If you can only simplify it, or you can't do anything to it, then your answer is going to have a square root in. What do I have to do with E? Oh, first of all, I guess I should have asked, is there an X term? Yeah, 5X. Well, when you take it over, yes. Right now it's 5X, but when you move it over, it becomes minus 5X. Plus 3.
No, I don't like these numbers.
Well, why?
They don't look like they.
Because if you think about it, 2 numbers that add to -5 but multiply to +3.
No, wrong.
That's not going to factor. So A is 1, B is -5, C is +3, quadratic formula. So -5 plus or minus inside the square root. What do I write?
-5 squared.
Sorry?
Make sure you add your parentheses.
Good. Minus.
4
Yeah.
times 1
Yeah.
times 3.
Okay, and that'll be all over 2 times 1. So the 2 negatives gives us 5 plus or minus 25 minus 12 under the square root over 2, which becomes 5 plus or minus the square root of 13 over 2. Where to now? Can't take it exactly. Can you simplify it? Is there a perfect square that goes into it? So we're done. That's as far as we can go. Oh, hi. And this last page was it's just a proof of the quadratic formula. Don't freak out. Right? But we do it by completing the square, actually. All right. So that takes care of everything